Hello and welcome to today's introduction to work and energy. So we're going to talk in this section, we're talking about work, power, and machines. Today specifically, we're going to just talk about work. So this is section 1, it's going to be on work. So the first question is, what is work? So if we're looking at this is what we're trying to answer is, what is work? So imagine trying to lift the front of a car without using a jack. So you stand underneath it, you exert a lot of force, and you pull, but the car doesn't move at all. It might seem like you're working hard, and you might even break a sweat doing so. But in science, work means something different. So in this class, when we talk about work, work is the transfer of energy from one object to another by a force that causes the object to move in the direction of the force. Okay? And so by doing this is our definition. So you need to write this definition down, and then we're going to have an equation that goes with it. And so we can calculate work by multiplying your force and your distance. So work equals force times distance. Work equals force times distance. Okay, and then if we think back, we just did a unit on forces. So if work equals force times distance, well, I can think back, what is a force? And so we learned last unit that force is equal to mass times acceleration. Remember, mass has to be in kilograms, and acceleration in meters per second squared. Okay, and so in this case, I can substitute this m times a in for this f, and I can get a whole new equation that is work equals, ooh, that blue's not a good color. That was a dumb idea. So we'll try it, let's go white. Work equals mass times acceleration times distance. So an easy way for me to remember this is, for a lot of people, work makes them mad. So work's equation, if work makes you mad, work equals mass times acceleration times distance. All right, now let's put this into practice. Let's use this. But before so, let's talk a little bit more concepts. And so work is zero when an object isn't moving. So any object that's not moving, no matter what's happening to it, there's no work being done. So again, we're trying to lift a car, we apply a large force. If the car doesn't move, our work is zero. Or you push on a car, it's got its brakes locked, and the car doesn't move, work is zero. However, once the car moves, even a small amount, you've done work. Some amount of work. Okay, so question. I have a weightlifter over here who's holding a bar above her head. At this moment in time, with the bar being here and her holding it, is she doing any work? And to answer that, the answer is no, because the barbell is not moving. Now, to get it there, some sort of work had to be done because the weights usually are on the ground and they have to get up to here. So yes, some work would have been done, but to hold it there, there's no work being done. And so that's the how could she show work. So she could move it, she could lift it up and down, she could push it and jump a little bit. All sorts of ways she can show work. Right now, she's not showing any. All right, so back to numbers. So because work is calculated by multiplying force and distance, our unit can be expressed as newtons times meters. So we have work equals force times distance. And so work equals, force is measured in newtons, distance is measured in meters. So work can be newton meters. Or we've labeled this combination is called a joule, which is our SI unit, our main unit for work. So whenever you see a joule, you know that a joule is equal to a newton times a meter. And then we said newtons is equal to mass times acceleration. So we can have kilograms times acceleration, which is meters per second squared. And we can take that times meters. So another way to write this would be kilograms times meters squared, because I have meters here and a meters here, per second squared. All those are units for the same thing. And if you do about 1 joule of work, or you will do about 1 joule of work when you lift an apple a distance of 1 meter. So roughly from your hip to your head, your knees to your head, is 1 joule of work. Okay, so let's use this. So here's a practice question. So imagine a father playing with his daughter by lifting her repeatedly in the air. How much work does he do with each lift if he lifts her 2.0 meters and exerts an average force of 190 newtons? So underline what you know, and then we have work, force, and distance, or we can say work, mass, and acceleration, and distance. Work, I don't know, because I'm looking for how much work. So I need to know this one. So work, I'm not sure. I know that I have 2.0 meters. That's going to be my distance. I know I have 190 newtons. That's going to be my force. So if we use our equation, work equals force times distance, I get work equals 190 newtons times 2 meters, which is equal to 380. Remember, this is joules, or you can say kilograms times meters squared per second squared, or I guess the easier way would have been newtons times meters. Any of those units would have worked for this question. All right, couple more. So our first one here is a crane uses an average force of 5,200 newtons to lift a girder 25 meters. How much work does the crane do on the girder? So we know a couple things. So again, we're going to write down what we know. We know that our force, so work, force, and distance. Our force is going to be 5,200 newtons. My distance is 25 meters. And I'm looking for my work. So work equals force times distance, which is equal to 5,200. 5,000, that's a 2. Work equals 5,000, yikes. 200 times 25, that's newtons, times 25 meters, and you should come out to 130,000 joules, or newton meters, or kilograms times meters squared per second squared. Second question. An apple with a mass of 102 grams falls a distance of 1 meter. How much work is done on the apple by the force of gravity? All right, so what do I know? I'm looking for work. So work equals, I'm not sure. Okay, make sure we circle our answers here. In the past, we've done force and we've done distance. In this case, I know that my distance is going to be 1 meter. But then it tells me 102 grams. Okay, I don't have grams over here. So instead of force, I can write, we'll cross this off, I can have mass equals, and I can have, that was wrong. I can have mass and I can have acceleration instead of force. So M and A. So my mass is going to be 102 grams. And A is going to be, in this case I didn't give you one, but we're talking about gravity. So remember, clear back when we talked gravity is 9.81 meters per second squared. Now, an important thing we need to remember is up here we have kilograms times meters squared per second squared. So this grams has to be converted to kilograms. So 102 grams is the same as 0.102 kilograms, and then I can set up work equals mass times acceleration times distance. So work equals 0.102 kilograms times 9.81 meters per second squared times my distance, which is 1 meter. So if I multiply all of those, I should come out to a work equal to 1 joule. Because of this 1 meter here, I only need one significant figure, so 1 joule is going to be there. This one had 2 on 25 and 2 here, so my answer needs to have 2 significant digits as well. All right, on the next slide, I'm going to give you a couple practice questions. Oops. Oh, this was the ones we just did, so 130,000 and 1 joule. There's our answers. And then here, I'm going to let you try these. Make sure you pause this video, work through these on your own, and when you resume it, I will give you the answers on the next slide. Okay, so here are your answers. So for the first one, you should have gotten 1,750 joules to the amount of work the brakes are doing. And then in the second one, we're looking for how much work the car does as well, and it should be 5,900 joules there. All right, so a couple last review questions. So what you should be able to answer these questions after watching this, and then we will continue this tomorrow. So first, what is the equation for work? What are my units for work? And then calculate the mass of an object that requires 122.6 joules of work in order to be raised 5.00 meters. Make sure you can answer those, and I will see you tomorrow.